Good morning, good afternoon, good evening. You're watching Makowe.com. Today we'll be discussing on electric motors. Today's topic is going to be electric motors. We're going to start with the definition. Um, in this topic, we will be discussing the definition of an electric motor, its applications, where we can find them, the coupling methods, the configuration of the different windings, how do we configure them, and then as well as the starting method. Then we also throw more light on the VFD, which is a variable frequency drive. How do we increase or reduce the speed of an electric motor? First, we'll be discussing on the definition, which is what is an electric motor. So, an electric motor is any machine which converts electrical energy to mechanical energy. So, at the input, we have electrical energy, and then at the output, we have mechanical energy. So basically, an electric motor, this is the motor. So it comes in the form of rotation. So at the input, we inject an electrical energy, while at the output, we'll get mechanical energy. That kind of machine is called an electric motor. So we have an electric motor which is used for several applications. We use them in residential buildings, we use them in commercial buildings as well as industrial buildings. For commercial buildings, we use them mostly for we use them in lifts, we use them in elevators, escalators, etc. And then in residential buildings, we use them in our normal grinders in the kitchen. We use them for ceiling fans as well as standing fans, washing machines. So we find electric motors used for several applications. So after understanding the definition of an electric motor, we'll move to the different types of electric motors. Basically, an electric motor, we have it in either AC or DC. So we have electric motors, they can either be operated in AC or in DC. So AC is alternating current while DC is direct current. So we also have universal motor. So the difference between the three different types is that for AC motors can only be operated by supplying an alternating current to the input in order to get mechanical energy at the output. The same way goes to DC motor. We should supply this electric motor with DC current, which is a direct current, to get mechanical energy at the output. So for universal motor, we can use them for both application, either as AC or DC. We can give supply to the input with either AC current or DC current. So we have two types of electric motor. We have synchronous motors and asynchronous motors. So some books you find them asynchronous motors or induction motors. So I'll explain the difference between these two, but basically our focus is going to be on asynchronous motors or induction motors. So for induction motors or asynchronous motors, it can either be operated or feed at the input with either alternating current or direct current at the input in order to get a mechanical energy at the output. So after understanding an overview of an electric motor, which is a definition, its application, where we can find them, we will now move to the coupling method of an electric motor. Before we move to the coupling of an electric motor, we need to understand how to carry out testing on the electric motor. I'll give an example of in a construction site whereby we have electric motors which are found in the layout or in the shop drawing where we want to carry out this installation works. So we start from the material inspection. So after bringing this electric motor from the supplier, we bring it to the site. So what we have to do is carry out inspection for this electric motor, which will be a material inspection. So the material inspection, we are going to carry out a material inspection based on the ITP that was submitted, which is the inspection test plan. In this inspection test plan or the ITP, we are going to find some checklist which we are going to follow the different steps to test this electric motor if it conforms to the requirement or the project requirement. So basically, we are going to be checking some points like checking the mechanical part of the electric motor, make sure that the rotor operates or the rotor is rotating freely, which is very important. And then check also the nameplate of the electric motor. So on the nameplate, we have several parameters like the power, the voltage, the frequency, the speed, the current. So we take down all these different parameters and make sure that it is equal to what is written on the material submitter. Based on that, we know it conforms to the standards or what we submitted to the supplier. This is what is delivered to on site. So we check the mechanical part of the electric motor and make sure that the electric motor is okay and can rotate freely without any obstruction. So after taking down all these different parameters, when we move now to the coupling methods, how do we couple an electric motor? This is very important to understand. First, we have to take down all the different parameters, like I did mention, the power, the voltage, the frequency, the speed, and the current. So we take down all this. The power, which is very important, this will tell us what will be the starting method which we are going to use. That I will explain after the coupling methods. So we get to understand what is the amount of power that we require to run a particular motor either on star or in delta. So now we're talking on couplings or winding coupling, coupling of windings. So how do we couple the windings of electric motor? So we go to the terminal board of the electric motor. We will find different windings or different wires which are being wind or rewind inside the electric motor. And then we have to configure it so we meet to the project specification or the desired goal of the electric motor. How do we want it to operate? So we have different coupling methods. It can either be star or delta. So we have two different configuration of the windings for electric motor. We can either couple them in star or couple them in delta. We need to understand what is star and then what is delta. For star, we know for star, the line current is equals to the phase current, while the line voltage is equals to root 3 phase voltage. So when we couple our windings of an electric motor in star, it means that the amount of current that we will find in the line, this will be the same amount of current that we're going to find in the phase as well. So the line current is going to be the phase current. So it only comes with difference to the voltage. That is, the line voltage is going to be root 3 times the phase voltage. While in delta is the opposite of it. So the line current is going to be root 3 phase current, while the line voltage is equals to the phase voltage for delta. So how do we configure our electric motor now, either in star or in delta? Based on the application of the electric motor, how do we want it to operate? Based on the different current, either we want the line current to be equal to the phase current, depending on how we want our electric motor to operate. Okay, on the coupling method of the electric motor, like I did mention, we can either couple them or configure the windings in star or in delta. So in star configuration will look like this. We have a node, it comes down. Okay, the idea behind it is to identify the different windings, the start and the finish of the windings. And you will note that in the terminal board of the electric motor, we are going to find 6 different sets of wires, since the electric motor we'll be discussing here will be a three-phase motor. So we are going to find six different sets of wires. So the start, the end, the start, the end, the start, the end. It makes it six different. One, two, three, four, five, six. So how do we couple it in star now? In star configuration. So we'll have the U windings, V and W winding. So it's going to be as such. So all these different phases are going to come as such, and we have a node which stands as the neutral point, which is going to be added or the added or connected to the frame of the electric motor. So here we have the different phases, the U phase, the V phase, and the W phase. So we have the UVW phase. How do we identify this electric motor? Sometimes electric motors will come without having any labeling to identify the different windings. So what we have to do is making sure that we identify the different windings, then we'll be able to configure or to couple this winding either in star or in delta. The next point now is going to be what are the different tests that we are going to carry out on the electric motor. To carry out testing, basically we have two different types of tests. We have the live and we have the dead test. So for the dead test, which we are going to commence first, since the electric motor is not supplied with electricity, so we can either carry out this test when the electric motor is installed on site already, or probably during the material inspection. So we have two tests that we are going to conduct for the dead test. It's going to be insulation resistance test, resistance, and the continuity test. For the continuity test, we are going to carry out the continuity test to ensure that we have the windings which are properly rewind or wind coupled in the electric motor without having any break. That is, we don't have the windings having any cut along the line. So we have them properly installed inside the electric motor without having any break. So the continuity test will ensure that the windings are all continuous. So it leaves, we rewind in the electric motor, it leaves, it coils, and then come back. So we have the start and then we have the end point. So we will be able to identify this set of winding, either U1 and the other will be U2. So as such, we are going to identify all the different other windings like the U windings, the V winding, and as well as the W windings, the start and the finish. The next, we are going to conduct insulation resistance test. The insulation resistance test will conduct it and make sure that it is greater than or equal to 1 mega ohm by testing the different windings. We can test the U winding with the V winding, the W windings with the U windings, the U winding with the V windings. So and then later test the different windings and the frame of the electric motor or the earth of the electric motor. We test all that and ensure that our value is greater than or equal to 1 mega ohm. After this test is passed, we can now move to the live test. But before we start with the live test, we have to configure or couple out the windings of the electric motor in the nameplate. And how do we achieve all this? I explain first for star configuration. We are going to have our nameplate as such. For star, we have our star windings like this. We have U, V, W, for example. So what will happen is the start of each winding, the end of each windings are going to be connected together. We have a node here, which is N. So the end of each winding is going to be connected together. So how do we achieve that here on the nameplate? We are going to connect all of the windings. For example, we have U1, V1, and W1. So here we are going to have U2, V2, and W2. So all these points are going to be connected together like we see here on the winding configuration. So to achieve this in delta, which is the main issue when it comes to coupling these windings, I'll give an example of probably you have an electric motor which is brought to you to rewind, or you want to rewind the electric motor to start from crash. After you do the rewinding of the electric motor, you come now on the nameplate. Before, the idea here now is to make sure that we have a desirable means of coupling these windings either in star or in delta. So this is what we are going to be achieving right here. So in this point now, what we have to do is in delta, we have our winding as such. So in delta, what we have is we have our set of windings. Okay, if we have the winding as such, for star, let me start first with star. For star, we are going to couple all of them together as such, having our U1, U2, V1, V2, W1, W2. So we are going to have the winding as such. So for delta now, how do we achieve this? For delta, we are going to have our windings as such. So the start of each winding, like we have our windings as such. The start of each winding is connecting to the end of the next winding. The start of each winding is connecting to the end of the next winding. So we are going to have it as such. Having the start, we will call this U, V, W. So 1, 2, this is 1 and 1. So the start of each winding is going to be connecting to the end of the next winding. Let me call this as U. U1, V1, and W1. So the start of this is going to be connected to the end of V winding. The start of this is connecting to the end of the W winding, and then the start of the W winding is going to be connecting at the end of the U winding. So we are going to achieve it as such. So how do we put this now in the terminal board of the electric motor so we can achieve either connecting the electric motor in star or in delta? This is the idea here now. So we have our terminal board as such in the electric motor. So here we will have our U windings, which is U1, V1, and W1. So achieve this now, our idea is, first of all, we need to achieve for delta. By so doing, we will achieve as well for star configuration. So how do we achieve this for delta? Since the start of each winding is connecting to the end of the next winding, so it means that the start of this is going to be connecting to the end of the next winding, which is V2. The start of V1 is connecting to the end of W winding, which is W2. The start of W1 is connecting to the end of U winding, which is U2. So after connecting like this, we'll be able now to configure or to connect our windings either in star or in delta. To connect in star, since we already know all the windings or the end of each windings are all coupled together, so we'll connect them as such to have our star configuration. So now in delta, how do we achieve this now? In delta, what we have to do now is, since the start of each winding is connecting to the end of each winding, so we will connect it as such to have our delta configuration. In this case, we will have our supply that is leaving from the U1, V1, and the W1 windings. So we are going to connect it as such to achieve our star or delta configuration. Okay. The next now we'll be discussing on the starting method. How do we start an electric motor? It's very important. So after taking down the different points or the different parameters on the nameplate of the electric motor, the power, the voltage, the frequency, the speed, the current. What we have to do now is we take into consideration the power. What is the power of this electric motor? Is very important. So we are talking in the case of Qatar. The different starting methods that we could either connect our electric motor in star, in delta, or stator resistance starting, auto transformer starting. But in this lessons, we'll be discussing mainly on direct online and star delta starters. As per Karama rules and regulation, it states that any electric motor which is having a power of 11 kilowatts and above should be operated in star delta starter. Any electric motor that is having less than 11 kilowatts, we should operate that electric motor in direct online starter. So what we have to do is, after taking down all the different parameters, we'll be able to ensure or to know that our electric motor, the power of it, if it is greater than 11 kilowatts, we will operate or employ the starting method of star delta starter. If it is less than, we operate it by using a direct online starter. It's very important to understand. So when we are supplying or giving the power to the electric motor, we should be able to know the particular starting method to be used for that electric motor to serve the application. Okay. The next now we'll be discussing on, we'll be talking now on the how do we test the electric motor now on live, because we already discussed for the dead test, which is a continuity test, and the insulation resistance test or the mega test. So successfully carried out, and we passed that. So we'll now move to live test, which is giving power now to the electric motor. After identifying the starting method, now we start it. I'll give an example of starting the electric motor in star delta starter. To start in the star data starter, after taking down all these parameters, what we have to do is we take the current for both star and in delta, all the different current for the different windings. In U winding, V and the W windings, or L1, L2, L3. So take down all these different windings, the different current, I1, I2, I3. So we take it in star and in delta, put it down, give power to the electric motor by supplying it in star delta starter, and then we have to test now the electric motor, the different currents in star and in delta by using a clamp ammeter. So what we have to do is count to the different phases. For example, this is the electric motor, so we've given power to it. So on this point now, we'll take our clamp ammeter, we connect on each of the different phases, and then take the reading. The next will take to the next phase and to the next phase. Take down the different readings for star, and then as it tends to go to delta after some time, after some predetermined time, it will switch to delta. We take as well the different currents also for L1, L2, L3, or U, V, W windings. So after taking that, we now compare with that of the nameplate, which is written by the manufacturer, and to ensure that our current that we measure should be greater than or equal to that of the manufacturer, since we are carrying out the test on no load. So after ensuring that we successfully passed this test on no load, which is having our current for different phases or for the different windings less than that of the manufacturer, we pass the test. Now we can supply our electric motor by running it on load. That is giving load to the electric motor and then do again another test to ensure that everything is okay. This is just a basic introduction of electric motors. So we get to understand what is an electric motor, its application, how to configure the different windings of the electric motors, and also the different starting methods that we have. Why do we employ them? As per Karama rules and regulation, we should ensure that we have a power which is greater than 11 kilowatt. We should operate that electric motor in star delta starter. When it's less than 11 kilowatt, we have to operate that electric motor in direct online starter. And Then also we should also understand the different means in increasing or reducing the speed of an electric motor. This is also very important. I'll throw a little bit of light to this point. So the speed of an electric motor. How do we increase or reduce the speed of an electric motor? Basically, we have our formula as 120. So we have an electric motor, sorry for the interruption. We have an electric motor, the formula is as such. So we have our formula, which is the frequency, the speed. The idea now here is the speed, which is equal to 120 frequency divided by the pair of poles. So we have this is a speed which is n, 120 degree or 120. This tells us that we have a phase shift between each phase of 120. So the frequency, which is F, divided by the P, which is a pair of poles. Pair of poles here will tell you the different number of poles or the different pair of poles that we've done in the electric motor. It can either be 2 pole, 3 pole, 2 pole, 4 pole, 6 pole. So to increase the speed or reduce the speed, what we have to do is we can either reduce or increase the number of pair of poles of the electric motor. But that we have to uncouple the electric motor, rewind it back again in order to achieve our desired speed that we need. But that will take a little bit time and will take a little much more time when we are carrying out probably maintenance. We want to increase or reduce the speed based on what we need for this electric motor. So basically, the best idea here is to increase or reduce the frequency, whereby we have an amazing device or an amazing machine or component which is used for this application, which is called the variable frequency drive, which is the VFD. In this case, we have the VFD. It is used to increase or reduce the frequency, thereby increasing or reducing the speed. Since we know the speed is directly proportional to the frequency, it means that if we increase the frequency, we thereby increase as well the speed. If we reduce the speed, the frequency, we reduce as well the speed. The frequency, variable frequency drive now will do this work for us. So in the variable frequency drive, we have a dashboard, and then we have a frequency point whereby we can increase the frequency. It will automatically increase or reduce the speed as we desire. Thank you very much for watching this video. This video, like I did mention, is just is an introduction on electric motor, how to carry out the different testings, the speed, how to increase or reduce the speed of an electric motor, what's an electric motor, the different applications and all that. So basically it's just to throw light on electric motor, so we get to have a clear understanding on electric motor and how to carry out testings on electric motor. Thank you very much, and I hope this video um, pass a message across, as well as if there are any comments or critics, you do mention it in the comment below so we can best improve on the quality of these lessons. Till then, you're watching makoge.com. Don't forget to like, subscribe, and then also turn on the notification bell so that each and every time that we upload any new video, you're going to get a notification. Thank you very much. Till then, you're watching makoge.com.